Okay, today's problem has to do with energy, and this is a mishmash of different problems, so we're going to try to handle them. The first one, a motorcycle and a car are street racing and moving at the same speed. The mass of the car is exactly 3 times the mass of the motorcycle. A, how many times greater is the car's kinetic energy than the motorcycle's? So the way I start off with these kind of problems is I like to put a make some kind of a diagram of what's going on. So I mean, you could have the motorcycle here and then the car here, right? And then I like to give a velocity here, velocity of the motorcycle. Okay, it's a vector going that way. See my sub-specifiers, velocity of the motorcycle. And over here, I'll put the velocity of the car. Okay. And I'll give this the mass of the motorcycle. And I'll give this the mass of the car. All right. And in the problem, they say that they're moving at the same speed. So with that, I can start to generate some equations. So I would say the velocity of the motorcycle equals the velocity of the car, and I'll just make that equals v, right? So, and that could be equation 1, right? All right, so the other thing they say is the mass of the car is exactly 3 times the mass of the motorcycle. So we get another equation. So I get the mass of the car is exactly 3 times the mass of the motorcycle with my sub-specifiers. Equation 2. So it says how many times greater is the car's kinetic energy than the motorcycle's. All right, so well, first is what is the definition of the kinetic energy here? And basically we have 1/2 mv squared, and there's your kinetic energy equation. All right, so to get the factor of how many times bigger is the kinetic energy of the car over the motorcycle, I'm gonna create a ratio. So I'm gonna just say the kinetic energy of the car over the kinetic energy of the motorcycle equals 1/2 the mass of the car, the velocity of the car squared, over 1/2 the mass of the motorcycle, and the velocity of the motorcycle squared. Okay, so that would be the setup. So this way we find some ratio. And that ratio will be how many times greater the car's energy is over the motorcycle. Okay, so we'll find out that factor. All right, well, then we got to substitute into this equation, all right? First off, I can cross out some things here. I got the 1/2, that's gone, right? The 1/2 is gone. 1/2 over 1/2 is 1. All right, so how about the mass of the motorcycle? Well, the mass of the car, let's put it in terms of motorcycle, is 3 masses of the motorcycle. So this here factor becomes this. Okay, and then you have the velocity of the car, which is just v, right? V squared. Okay, so now we have the mass of the motorcycle, and we have the velocity of the motorcycle, which is just v squared, as from equation 1. We substituted out the motorcycle's v, and the car is v. All right, so right away, I see some more stuff that can come out. That's gone, and the mass is gone. And what's left is a 3/1. So We multiply both sides by kinetic energy mass of motorcycle, and then we get kinetic energy of the car equals 3 kinetic energy of the motorcycle. So it's, the car's kinetic energy is 3 times the kinetic energy of the motorcycle. Okay, that was part A. This is part B. Part B says if the motorcycle speeds up so that it's now traveling 3 times as fast as the car, how do their kinetic energies compare now? By what factor? Okay, so now we do not have the equation 1 here. We have another the velocity of the motorcycle now. Let's put it in the second thing. Equals 3 times as fast as the car. So velocity of motorcycle equals 3 velocity of car. And now that's our new equation for B. Okay, so we have to realize that. So the mass of the motorcycle didn't change. The mass of the car didn't change. So again, we're going to our ratio. So let's go kinetic energy of car over kinetic energy of motorcycle equals 1/2 the mass of the car, the velocity of the car squared, over 1/2 the mass of the motorcycle, velocity of motorcycle squared. There's your equation from your kinetic energy equation. Now let's see. The mass of the car, okay, is still 3 times the mass of the motorcycle. So I have 1/2 3 times mc, mass of motorcycle. Okay, but the velocity now of the car, we're going to keep it to velocity of the car squared. Okay, but let's go down here. 1/2 m, mass of the motorcycle. Now the velocity of the motorcycle is 3 velocity of the car. So we're going to substitute 3 velocity of the car and square that. All right. So now we can get rid of some things. I see the 1/2 is gone. The mass of the motorcycle falls out. And we still have yet to multiply this, so we get velocity of car squared over 9 velocity of car squared. Okay, velocity squared drops out, and we get 1/9 times 3, the 3 on top. 3 because the mass is 3 times more, so we get 3 over 9, so that's 1/3. Okay, so let's see. We get kinetic energy of the car equals 1/3 the kinetic energy of the motorcycle. So even though the motorcycle is 1/3 the mass, but if you increase the speed three times, now the car doesn't even have 1/3 of the kinetic energy of the motorcycle, and that is because the mass is linearly proportioned, but the speed is to the square. So for instance, if you double the speed, you increase the kinetic energy by 4. So if you take the speed, double it, the kinetic energy increases by a factor of 4. If you triple it, right, then you have a factor of 9. It increases by a factor of 9. It's the square of the speed. So that's where this is coming from, and your kinetic energy goes up pretty fast. So that's that problem. Thank you.